Hey, welcome back. Today we're going to be discussing thermal energy. Specifically, thermal energy is heat. Okay, the first one we're going to talk about here is temperature, a measure of how hot or cold something is. Um, Temperature is a measure of the average kinetic energy of the particles in an object. Now, if you remember, kinetic energy is the energy of things that are in motion. So, when we talk about the average kinetic energy, we're talking about these particles moving. And the reason that we have temperature or something increases in temperature is as they're moving, there's these collisions. And when there's collisions, that equals friction. And friction equals heat. So as there's these collisions, there's all this friction. And as we get more friction, the temperature is going to increase. As they were to lose kinetic energy, there'd be less collisions, less friction, less heat, and the temperature would go down. And that's essentially what this slide right here says. All particles have kinetic energy. They're all constantly moving. As they have more kinetic energy, they're moving more, which means there's more collisions, more friction, more heat, and vice versa. Okay, thermometers rely on expansion. Most substances expand when their temperatures increase. As thermometers shows increase in temperature by metal expanding in the thermometer. Well, down here, what's going to happen is you've got the substance, and they make the red, but it's really just a dye anymore. And as it heats up, it starts to expand. And because it's expanding, that's how we can tell the temperature. Well, there's three temperature scales. There's Fahrenheit, there's Celsius, and there's Kelvin. We're going to discuss these three in the next couple slides. Fahrenheit's the one we use every day. This is one for standard. All right, this is the standard standard not metric system, the standard system. Fahrenheit is measured in degrees Fahrenheit. Water freezes at 32 degrees Fahrenheit and it boils at 212. So these are just some common temperatures we ought to know. It freezes and thaws at 32. It'll boil and it will condense at 212. Next one we're talking about here is Celsius. Celsius is degrees Celsius. Quite often we think of this being the metric system, and it is the metric system, but it's not the common base. Water does freeze at 0 degrees Celsius, and water boils at 100 degrees Celsius. Here's our equation that relates the two of them. All right, temperature Fahrenheit equals 1.8 times the temperature in degrees Celsius plus 32. Okay, let's do some practice problems here. I'm going to do the first two. You can do the last two. The first one, we want to change it from Celsius into Fahrenheit. So I'm going to put 23 degrees in for the Celsius. And we get 73.4 degrees Fahrenheit. The next one tells us to put 50 degrees in for Fahrenheit. In this case, I'm going to subtract 32. And that's going to give me 18 equals 1.8 times the degrees Celsius, divide by 1.8. And the temperature in degrees Celsius then is 10 degrees Celsius. Hey, you go ahead and work out the next two, the two that I've underlined here. You can work those out the exact same way. Okay, the next thing we're going to talk about here is Kelvin. The Kelvin scale is based on absolute zero. This is a key concept right here. Key concept. I'm not trying to do that. Here we go. Key concept right here. Absolute zero. Absolute zero is the temperature at which molecular energy is at a minimum. No movement means no energy, because for temperature is based on kinetic energy, which is movement. If things are not moving, then there is no kinetic energy. If there's no kinetic energy, there's no temperature. And that's why we call it absolute zero. When things stop moving, they're at the lowest temperature they could be because there's no movement, which means there'd be no collisions, which means there'd be no friction, which means there'd be no temperature. Down here at the bottom is our equation. Celsius to Kelvin conversion equation. Right. Temperature in Kelvin is equal to temperature in Celsius plus 273. Again, let's do some quick math with this here. I'm going to write the equation up here. Temperature in Kelvin equals temperature in Celsius plus 273. The first one wants us to convert to Celsius. As you can see, we get negative 250 degrees Celsius. So when something's at 23 Kelvin, it is really, really cold. It's way below freezing. The next one wants us to find out what the temperature is in Kelvin. So I'm going to put 450 in for Celsius plus 273. And temperature for Kelvin turns out to be 723 Kelvin. Notice that I'm not putting degrees with that. Alright, again, you've got 2 to work out on your own there. If you have questions about them, raise your hand. Okay, what makes things feel hot or cold? The feeling associated with temperature differences result from energy transfer. When 2 objects that are at different temperatures that are touching, energy will transfer from one to the other. A temperature change. Again, a temperature change indicates an energy transfer. All right. If something raises in temperature, somehow it's gained energy. Energy's been transferred to it. Heat. The energy transferred between 2 objects that are at different temperatures. Transfer of energy as heat. It's always hot to cold. So if you've got a piece of metal and you were to put your hand on the piece of metal, what's going to happen here is you're going to feel the cold metal. Well, what's actually happening is heat, all right, heat is leaving your hand and going into the cold metal. That's why when you raise your hand, that part of the metal will feel warm. And the reason your hand felt cold is because it was losing heat. All right, it's losing heat. If you lose heat, you get cold. All right, 3 questions here for you guys to answer. Hopefully that was very informative for you guys, and I'll catch you on the flip side.